In this video we are going to see how to find nth ugly numbers. So first we need to know what are ugly numbers. If any number, so let's say number is n, can be broken down into its prime factors. So any number can be broken down into its prime factors, but if the prime factors are just 2, 3 and 5. So if this number can be formed using just 2, 3 and 5 and nothing else, so there should not be any other prime factor like 7 or 11. Then in that case that number will not be ugly number. So if this number can be represented only using 2, 3 and 5, then this is a ugly number. So what is the smallest possible ugly number? 1, because I can write 1 as 2 to the power 0. So this is the smallest ugly number and this is the base case. And then next will be 2, because we can write as 2 to the power 1 and others power 0. Then 3, because this is just 3 to the power 1. Then 4, because it's 2 square. Then 5, it's 5 to the power 1. 6 is just 2 and 3. 7 we cannot represent, it's a prime number itself, so we cannot factor out, and we have to just use 2, 3 and 5 as the prime factors. Now 8 is again 2 cube, then 9 is 3 square, then 10 is 2 times 5. 11 again is not ugly because we cannot break it into 2, 3, 5 and so on. So the numbers are 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 14 and so on. So how can we find, uh, let's say what is the 10th ugly number? Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we should print 12. So how can we do that? So let's first understand. So if we start with the base case, that is 1, then we are allowed to multiply 2, 3 and 5. So first we multiply by 2, we will get 2. If we multiply by 3, we will get 3. Then multiply it by 5, we will get 5. So if any number k is ugly, and if we multiply them by any power of 2, if we multiply them by 2 any number of times, or 3 any number of times, or 5 any number of times, then this complete number will also be ugly, because if this k was 2 to the power p1, 3 to the power q1 and 5 to the power r1, then multiplying this by this will just increase the powers of p, q and r depending on what we multiplied. So again this can be represented as some power of 2, 3 and 5. So multiplying any ugly number by either 2 or 3 or 5 or multiple of them will again form a ugly number. So 1 is our base case. So I multiplied by 2, we got 2. So 2 is ugly number, 3 is ugly number, 5 is ugly number. Similarly, in 2 we can multiply by any of these, and we cannot multiply by any other prime. We are allowed to just multiply by 2, 3 or 5. So we will get 4, 6 and 10. Similarly in 3 we can multiply any of these. We will get 6, 9 and 15. Similarly for 5 we will get 10, 15 and 25. Then 8, 12, 20, then 12, 18, 30, then 20, 30, 50, here also 12, 18, 30 and so on. So it will quickly be growing exponentially. At every level it's growing by 3 times of the previous level. So now we are not missing any of the ugly numbers by branching out like this, because any ugly number will be formed from this base number by multiplying some factor of uh, 2, 3 and 5. So this, if we complete this tree, then this tree represents all the ugly numbers. It will not miss any, because if say we have ugly number k, then it will be represented as, let's say, 2 to the power 2, 3 to the power 1 and 5 to the power 1. Then this will be present in this tree because 2 has power 2, so go leftmost branch once, then again, so it will be 1 into 2, and then if we again take left branch, it will be 2 into 2, that is 2 square. Now 3 has power 1, so take the middle branch once, so we reach here, so this is till this point. Now 5, so this will again have 24, 36 and 60. So now we have 5 to the power 1, so take the rightmost branch, so we will reach here, and now you can calculate this is equal to 60. So 5 times 3 is 15, 15 times 4 is 60. So in general, if we have any ugly number, 2 to the power q, 2 to the power p, 3 to the power q and 5 to the power r, then this is equivalent to take leftmost branch p times. So we will get 2 to the power p, then take middle branch q times, then rightmost branch r times. So we can form any ugly number by just traversing through this tree. So this tree represents the complete picture. Now how can we find nth uh, ugly number? So this represents the tree, but we don't know exact order, that which is the smallest, which is the next smallest. So what we will do, we take the base case 1 and we can multiply by 2. So we print 1. So this is the base element, we printed 1. Then we will multiply 1 by 2, 1 by 3 and 1 by 5. So we can create a table. So this is u1 and this row corresponds to multiplier. So we have only 3 multipliers, 3 factors, 2, 3 and 5. So we take u1, u1 is 1. We take u1 and multiply it by 2, 3 and 5. So 1 is fixed here. Then we take u2. So whichever is minimum of these, we will take that as the u2, because we cannot form any number smaller than this, because u1, u2, u3, this will be increasing in this side, and this 2, 3, 5 I have kept in increasing order, so this is also increasing. So this should be the minimum of any of these numbers in the table. If we draw this complete table, so if we see this row, then the values are increasing on the right side, because this will be 2, again multiplier will be 2, again 2, but this u2 will be greater than u1, so this value will be greater. Similarly for the bottom, because this u1 will be fixed, but 2, 3, 5 are increasing, so this is the smallest, so we will print that. So first was 1, then we pick the minimum of this table which is not printed, which is 2. So we mark this out and we move here. Now we know U2. So we can put U2 here as 2. So 2 times 2, 2 times 3 and 2 times 5. Now what is U3? We don't know U3, so we will compare. So in this row we have already printed this. So next minimum is this value. And in this row minimum is this. And here this. So we compare these three. These three are the smallest numbers. So we compare against 4, 3 and 5. So minimum is 3. So we print 3. Now we know U3. U3 is 3. So we cut out this because we have printed this. And in this row we move the pointer here for the next comparison. So the rows which I cut will be in blue. So now we compare against 4, 6 and 5. So minimum is 4. So we print 4. Now we know U4. U4 is 4. And here we have multiplied by 3. So 4 came from here. So we will cut out this and move this row's pointer to here. And these remain same. So now we will compare against 5, 6 and 6. So minimum is 5. Now we will cut out this and move the pointer here. So now we have 6, 6 and 10. So minimum is 6. So we will print 6 and cut out these twos and it will move here, and in this row it will move here. Now we have 8, 9 and 10. So minimum is 8. So this will advance here. So now this is printed. Now we have 10, 10 and 9. So minimum is 9. We will print 9 and move it here. So in this way we can keep on going. So you will see that we have 1, 2, 3, 4, 5, 6 and we have skipped 7 as expected. Then 8, 9. Because we are taking all the possibilities. I am just redrawing this tree. So whatever is this tree, I am drawing it as table. Because this table is, we pick any first ugly number, then multiply it by all the three possibilities. So that is what we are doing here. We picked u1 and multiplied it with 2, 3 and 5. That is the only three possibilities. Then from these we find the minimum. So we got u2 as 2. Then in the next column we multiply u2 by all three values. So whatever we were doing here, we picked 2 and multiply by all three values. So we are just redrawing this tree here, and we showed that this tree represents all the ugly numbers by this logic, because any ugly number is of this form, and this means simply that take the leftmost branch p times, then middle branch q times, then rightmost branch r times, we will get that ugly number. And in this table, its value is increasing to the right and also to the bottom. So that's why we are always comparing the next minimum value. We are keeping a pointer in each row and advancing gradually. So in this way we will find all the ugly numbers in their actual sequence. So now let's write this in the code. So the function definition would be like, if we have integers get ugly, and we will put here position. Like if position is 10, that means we want the 10th ugly number. So for that we will start filling this array. So this was an array. We will stop when we reach this count or position. So we will take one array for storing the ugly numbers. For simplicity, let's call it n of size n, and we will initialize with the base case. Ugly 0 is equal to 1. So this is the base case, and now let's keep a counter. So we have populated one value, so count is 1 now. Now let's take these three indices. For each row we were keeping track that where we are currently when we printed this. So initially they were at 0th index, because we were picking this ugly 0 is equal to 1. U1 represents, this is U1, this is U2, this is U3. So U1 means we will store at 0th index in C++, and U2 is at index 1. So initially these three indexes, index 2 will be 0, index 3 will be 0, index 5 will be 0. So these correspond to ugly number 1. Now what we do, while count is less than n, so we have to calculate till n. We want nth ugly number. So what we will do, we will keep three variables, three values corresponding to these cells. So we take u1 and multiply it by 2, and also by 3, and also by 5. So next 2 will be ugly idx2 multiplied by 2. Next 3 will be ugly idx3 multiplied by 3, and similarly next. So now we have to find the minimum of these. So we took one value from each row, and now we will see which is the minimum. That will be the next ugly number. So next is equal to next 2, next 3, next 5. So I am using the standard min function that is defined in algorithm header file inside C++, and it takes an initializer list. So it will give one of these three as the minimum. So it will either give next 2, next 3, or next 5. So now which index to increase? So when we printed this, we moved this pointer, but others did not move. In some cases we were getting equal values, like here 6 and 6, and 6 was here, we were printing that. Then we will advance both of these. So if next is equal to next 2, that is we picked the value from first row, then we will advance idx2. If next is equal to next 3, then we pick the value from second row, and we will advance idx3. And if next is equal to next 5, then we pick the value from third row, and we will advance idx5. And then we will, whatever next we calculated, we will add it to our array. So we can do count plus plus. So it will add at position 1, then increase the count to 2, and next time it will add at position 2. So we have increased the count, we have added the value to the ugly. Now we can close this. So this will loop will terminate when count reaches n, and when count reaches n, that means we have populated, completely filled this ugly table. Then we can return the nth value, and that ends our function. So this is how we can find nth ugly number using dynamic programming. And what is the time complexity here? Because for finding any ugly number, we are doing just comparison, one comparison among three numbers, and three multiplications. So its time complexity is order n, and space complexity is also order n, because we are storing all the values in this ugly array of size n. So thanks for watching, and give your valuable feedbacks in the comment section below, and don't forget to subscribe my channel if you like my contents. Thank you.